Welcome, ladies and gentlemen, to the Ask ServiceMonster show, where you've got questions for your service business and we've got your answers. So no one had a question today that we haven't actually already done a video on, although we might start re-upping some of that content. But I wanted to take a minute and just talk about something that's been on my mind for, the last few months.
Quantum computing.
I thought it'd be nice to take a break. I've seen several topics on the boards that are like, please, can we stop talking about politics? And for a minute, can we just take a breather off of business? And so I agree with that. And on occasion, I will dive into some physics books and figure out what's going on in the crazy world of physics. And now my two passions of physics and computing have collided into this quantum computing topic. So for the non-nerds, we'll just get the small stuff out of the way. Why is quantum computing important to you? And moving forward in your business, why is it going to be a thing you might want to pay attention to? Speed. So remember back in 1995 when you had that 28.8 kbaud modem and you were watching VHS tapes at 240 resolution? Yeah, today's speed is that by comparison for quantum computing speeds that are just in their infancy. The speed increase is ridiculous. And while this won't mean downloading business apps faster over the internet, it will make the queries on those servers much faster. Now we're a ways away from seeing anything in production, but keep your ear to the ground because it's happening faster than we think. The number 2 reason why you might care, decryption. You see, current technology is based off never mind, we'll get to the geek stuff in a minute. But at the end of the day, current encryption technologies are like paper to a quantum computer. They'll chew through those algorithms so fast because security today is based off probabilities. Everything's hackable, it just takes time. And the encryption algorithms that we currently use, that time calculates to somewhere around, 2 billion years. But a quantum computer can do it in minutes. Another reason you might care? Encryption. But along with the additional math computation that you're able to do at the speed at which you're able to do it, there's something else kind of a little weird. You can send a message over the ether and know if someone peeked at it. That's pretty powerful, especially if you're using that knowledge to encrypt or decrypt messages. So if someone reads it, they don't get the message, but you know what? Neither did you. And you know on the other end that someone tried to look at it. And so this is good for obviously military applications and huge national security issues. Now again, we're a long way from having any of this stuff in production, but China has cracked quantum computers 101 for dummies. They've done several experiments that prove that we are entering a new era and that all the theoretical physicists that have been playing around with this stuff for the last decade, it's all true. And we're all able to now use some of the stuff that we understand and frankly that we don't understand and leverage that for computing power. All right, so if you're still hanging out, now let's deep dive for some of the nerds. What is quantum computing at its core level? There's 2 quantum physics principles at play here. The first one is superstate, or particle state and its spin and representation, never mind. But the other one is entanglement, which is really spooky and weird. The first one, quantum state. So computers operate right now on a transistor-based technology. It's binary. It's either a 1 or a 0. And with 1 bit high and n bits long, we're able to send messages over the internet and download HD video to your heart's content. It's pretty phenomenal what we've been able to do with that transistor. We've been shrinking it down as small as we can go, and some of the fastest computers now are about 5 atoms in size for their transistors. So we are quickly approaching the physical limitations of the system that we have built computing upon. Enter the qubit. You see, a particle can exist in multiple states, not just 0 or 1. They can exist in states in between 0 and 1. And this gives you mathematical computation power It's ridiculous. Like each bit or qubit position able to represent, let's say, 4 states as opposed to the binary 1 or 2, and the amount that you can save compounds over time, and it's crazy. So you can see from a mathematical point of view, this stuff gets crazy fast, and that's why a quantum computer can chew through a transistor-based encryption algorithm. It's over. Like, sell all your shares in Bitcoin and blockchain. Okay, up to this point, for the most part, this has been pretty tangible. We can understand it. It has some grounding in reality, and even at a particle state of superstate and multiple spins, you kind of get the idea. But then comes entanglement, something that Einstein jokingly called spooky action at a distance. And he proved that it can exist by kind of proving that it did. And we've been able to represent those theoretical calculations in the real world. Here's how it works. Take 2 particles birthed, let's say, from a light. You take 2 electrons or photons, and they're entangled. The pair is entangled, meaning that regardless of distance, they have influence over one another. They both represent some probability of spin. And once you observe them, the spin resolves in both particles. The opposing partner will spin in the opposite direction, but this is independent of distance. Across the galaxy, you can have a particle that responds instantaneously to being observed and then read that on the other side of the galaxy. The implications here are unbelievable, but what China's been able to do is these encryption packets that know if someone tried to look at it, and that way it could just spill the contents and destroy it. It's pretty fascinating stuff. Now, I'm going to go another level here, and we're going to go theoretical for a second. Now, if you do any digging or you understand this stuff even at a rudimentary level, physicists are saying that we can't transfer data with entanglement. But I'm thinking it's only a matter of time that we're able to influence these unknown particles to known positions without observation. If we can do that, then we're looking at instantaneous data transfer and communication across the galaxy, breaking Einstein's law of light speed as the maximum speedometer of the galaxy. Obviously, there's something going on here, and we have no idea how it works. Thought experiment. If you're with me so far, it's likely you're familiar with the twins paradox. You take 2 twins, you put one on a spaceship, you fly him to the end of the solar system as close to light speed as we can get, and then back. And by the time he gets back, maybe a short time, let's say a year has passed for him. His brother, though, will be 10 years older, proving Einstein's theory of general relativity, where time is relative to the position of the observer. And this is all true. We've done this with atomic clocks, and we know these experiments work. So, check it. 2 drives, quantum entangled, with data transfer capabilities. You put one on the spaceship, you fly it to the solar system, and it comes back. The physical drives, the material, is going to be that same ratio, let's say 1 year to 10 years. But what about the data? If the data is instantaneously transferred regardless of speed and distance, then am I getting the data that exists now? And what is now relative to the drive? Could we actually be receiving messages from the future? Something I'd like to ask Neil deGrasse Tyson. Okay, guys, just a little break from the harsh reality of politics and business. So I wanted to break that up and kind of dive into something that's just been on the top of my mind for the last few months and common topics of conversation around my household. So 3 things wrapping up this non-business piece. Number 1, it's nice to stop and take a look at what we have accomplished as a people, especially over these last few hundred years, and where we're headed. We've got booster rockets that land themselves vertically. Like, way to go, Elon. Number 2, my father, myself, and my son represent a pretty poignant example or sample in this moment in time. My dad's a technologist, but he doesn't like change. When he was growing up as a kid, not much changed. Me, Gen X, man, change was our only constant for the first time in human history. A lot of us adapted, and we're good at adapting and going with change. Some of us didn't. and the ones who didn't are having a harder time of it. Millennials have no choice. They were born in a world that changes on them daily. So the lesson here is, at the very moment something has entered a state of rest is the very moment it's ready for disruption. Use it as a tool. Resistance is futile. And number 3, everything's about business. How can you take this content and apply it to make yourself a better business owner and make your business stronger? From everyone here at ServiceMonster, thank you so much for your attention. Subscribe to our YouTube channel. Go check out the demo. Give us a call.